Hello everybody. So in the previous videos I've been showing you some background information on how we might go through talking about the relationship between two variables, talking about things like a least regression line, talking about the idea of a linear regression and how closely it fits so we get a correlation coefficient. Now what we're going to do is we're going to go through and I'm going to illustrate how we do this in Canvas, and it's actually in Excel by using the data set MBody from Canvas. So if you haven't gotten that data set out, please pause right now, go to Canvas, and you can open up where you found the lecture assignment, or you can open up the data sets at the bottom of our course modules and find our data set MBody and open that up in a spreadsheet. Okay, if you've done that, you should get this particular right here, right? You should see that we have all sorts of columns right here about age, pulse rate, systolic and diastolic pulse rates, HDL, LDL levels, white blood count, red blood count, platelets, and so on and so forth. Just all this health information, right? Lots and lots of health information about, these are male subjects right here. So we want to ask the question. We want to compare the variables age, waist, age versus waist, right? Because we might think, well, okay, I suppose that it might be sort of an interesting study to figure out, is there some correlation between a person's age and their waist size? I tend to think that sometimes, yeah, people who get older tend to get larger waist sizes, so maybe that might have some sort of correlation there. And let's talk about arm. Actually, it's arm C, so they talk about arm circumference and waist. So arm circumference versus waist, and let's talk about, is there a correlation between these two variables, right? And we're going to be asking the question, what is the regression equation from Excel? What is the correlation coefficient, and is that correlation a strong or a weak one? So let's run through the procedure in Excel on how this is done. So what I did first was that I opened up two extra sheets here. So at the bottom of my spreadsheet, I'm going to open up sheet 2, sheet 3. And at each of these ones, I'm going to put in my my data pair. Remember, one of the tricks that I've been trying to push here is if you use Excel to analyze data, you really don't want to overwrite or compromise your data set. That would be a bad thing. So what we're going to do is that we're going to copy over our data from columns A. So we have column A, which is age, and waist, column L. So we're going to copy those over, and I did that in sheet 2. So here's my two variables, age versus waist. And I just copy that over to a nice clean spreadsheet area here so that I don't have to worry too much about it. Now what I've done is I've just highlighted this. You see this? I've just highlighted my data. So what I'm going to do is I want to make a spreadsheet. I want to make a scatter plot. Making a scatter plot in Excel is one of the easiest things to do. We go to insert right here after we've highlighted our two columns right here. By the way, the first column will become our horizontal axis, and the second column will always become our vertical axis in our scatter plot. So what I'm going to do is I'm going to go over here to the center, and you'll see one here that says scatter plot. Insert scatter. So we're going to insert a scatter plot right here, and you see that we have a number of choices. We just want to choose the one in the top left right here. It says a scatter plot. We want a simple scatter plot, so we click on that. Boom, there it is, right? Scatter plot. Now, sometimes it's a little bit hard to read, right? Because it looks like, well, maybe there is some sort of correlation going on right here. But if we zoom in on the details, we might find some difference. So I'm going to show you how we change the details here. You'll notice along our horizontal axis, we have waist versus age. I'm gonna rewrite this little title right here. This is waist versus age. Right. So it's age on the horizontal axis. You'll notice that the bottom age is probably closer to 15 than it is to 0. So we're going to adjust that. What we can do is we can go to Format Axis. So let's click on the numbers, any one of those numbers. Right click with your mouse, go to where it says Format Axis. Says the minimum. Well, the minimum age that we're dealing with is probably closer to 16 than it is to 20. So let's use 16 as the basic age here. And yeah, it goes all the way up to 76, but I don't think anybody's age is higher than 66. So let's click on that. And you'll see automatically how that chart is spread out just like that. We're okay with the units right here. Maybe we can make the units a little bit closer if we wanted to. Make the units by every 5 or something like that. Let's make the units by 5. How about that? There we go. So we can see closer together what those ages are. And then let's spread out here. Let's see the vertical axis. So right up here, we click on the numbers on our vertical axis, and we can go to where it says Format. And again, our bottom is no smaller than 60, right? So we go 60 as our lowest value, and our highest value appears to be 140. So I'm going to go up to 140. There it is. And, well, this is our spreadsheet now, right? That's pretty good. We didn't really have to do a whole lot to get it. So there's our spreadsheet, right? Now what we're going to do is I'm going to show you. One of the questions was, what is the correlation coefficient? What is our linear correlation? So what you do is this. Click on any one of those points in your graph, right? You see it right here. And it says, you come up, if you right-click with your mouse, you come up with a menu right here, and what we're going to do is we're going to add trend line. That trend line, that's our linear correlation. So we're going to add a trend line, and you see some choices right over here for format. Of course, it's automatically on a linear trend line, so we're going to focus on a linear trend line right here. And then we can choose to get our R squared and our equation, right? So let's display the equation on the chart and display R squared. Here they are. I'm going to just click on drag that over. I can drag that little, if I'm very careful here, there it is, okay. I can drag that over, and I can even enlarge that data set so we can read it. Boom, 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 right? So I'm even going to make it bold. There we go. So I see I have an equation that goes like this. In this equation right here, in this relationship versus R squared explains our linear correlation right here. It looks like R squared gives us 22.2285. That seems like it's actually going to be kind of small. Our linear correlation equation, we get a B0 of 77.1 or so, and a slope of 0.4591. It's an increasing slope, right? Well, how close a correlation is that? Well, we can get the correlation coefficient very easily. The correlation coefficient R, I'm going to align that so I can read this. R, the correlation coefficient is found with a very simple command. Equals CORREL. See it down here, pops up in our menu, coral. So that's a correlation coefficient that we're going to get. We're going to get it for our two arrays. So we're going to go from A2 down to A41, and that is going to give us our first data point. And then we go to the second one, and then I'm just going to type this one, B2 to B41. There it is. It automatically comes up. I hit enter, and here's my correlation coefficient. So the question right here was, what is our equation for the first one? Well, y equals 0.4591x plus 77.099. The correlation coefficient was 0.47798. So what could we say about that? Well, that's actually just a very weak positive correlation. So while there may be some truth right here that there's some correlation between age and waist, it's a very weak one. It doesn't seem to be a very good correlation that we could actually use to describe what's happening with this correlation line, right? So if we went in there within our predictor and said, okay, if we want to find out at age 36 what our waist size was going to be, this would be a bad way to do it, right? It doesn't seem like it'd be a very good way of predicting that. All right. Well, let's try with arm versus waist. All right, let's go. Let's do the same thing. So I'm going to open up my data set right here again, and I copied over our waist. Let me get rid of this here. Waist versus arm circumference. So I picked these two, and I copied it over to sheet 3 now. And now, highlighting my data, make sure you don't have any blanks in there. Let's insert a scatter plot and see what happens this time. So scatter plot, we just want the basic scatter plot. Wow, look at that. All bunched up in the corner. We're going to have to make the adjustment again. This time it's arm circumference versus waist. Okay. Oh, I don't want to go too far here. Versus waist. Okay, there it is. All right, now I'm looking at this data set right here, and it says it's all bunched up in the corner. I want to zoom in on this. So looks like the minimum horizontal axis value is 60, and the minimum vertical axis, our arm circumference, is probably about 25. So let's adjust this. So we click on the numbers, we go to Format Axis, we choose a bottom number of 60. And it looks like the top number is maybe 140, so let's go to 140 here. There we go. Okay, that's stretched out there. Now let's talk about our vertical axis. So it's on our vertical axis. These numbers seem to be a little bit scrunched together, so we'll format that. It looks like the minimum number for our arm circumference is just under 25. So I'm just going to go ahead. I'm going to make that minimum 20. The maximum looks pretty good, right? 45 seems to be about the biggest that we've got in this set. So now we look at this data set and we say, well, does it seem like there's a pretty good correlation? There might be. Let's click on one of these data points. Right-click with your mouse. Go down to Add Trendline. Boom. We automatically get a linear trend line right in there. Looks like it is actually passing a little closer to that data point line. We want to display the equation and the r squared value. There they are. So let's take this piece of data right here. Let's put this up here. And let's increase the font size so we can read that. So I'm going to increase that to, let's say, 12. And make it bold so we can read it pretty well right there. Okay, so our correlation coefficient this time, our correlation, our best fit line, looks like it says we've got a y-intercept of 13.2 and a slope of 0.2149. R squared is 0.62. Seems a bit higher this time. Let's figure out our correlation coefficient. Our correlation coefficient, remember, goes R equals. And in the next cell, I'm going to enter equals C-O-R-R-E-L. That's the command. Again, we're going to take A2 to A41, comma, B2 to B41. Oop, close it with a parenthesis, not an underscore there. And hit it. That's not too bad, right? Here's our correlation coefficient this time. Looks like, in this case, 0.7884. That's a strong positive. Not exactly the strongest, but it is a strong positive correlation. As we should suspect, right? If somebody has a larger waist size, then we measure around their arms. Usually the arm's a little bit larger around too. And it's not necessarily due to muscular height. It could be just due to fat. And fat around the waist and fat around the arm circumference seem to correlate pretty well. That doesn't mean it always does, but this is what we would consider a pretty strong positive correlation. Now, let me get one last warning to you right here about correlation and causation, right? When we say correlation, we mean that the two variables, one affects the other. Kind of like what we said right here with our happy mood versus hours slept, right? There's definitely a correlation. One can see that one has something to do with the other. But correlation does not mean causation. In other words, the cause of one's happy mood may not have to deal with the hours of sleep. It may affect it, right? But it's not necessarily a cause. There may be many causes to one's happy mood, right? So correlation is a way of measuring how closely two variables have to do with each other, but they don't necessarily mean that one causes the other, right? I'll give you an example that a professor gave me once. A professor once told me that in statistics, said that if we were to look at the number of churches and mosques and temples in a city, the number of religious institutions in a city correlates very closely with the amount of crime in the city. Now, does that mean that the presence of religious institutions means that there is the presence of crime? Well, no, one certainly does not cause the other. There's probably some other underlying feature about that data set. We could say that, for example, they both correlate to just the amount of population. A higher population density is going to correlate with both the number of religious institutions and the amount of crime. And that other underlying factor does not mean that the other two have something to do with each other or one causes the other. So be very careful in your conclusions about this. In any case, that's our lecture on correlation, and have a great week.